Using a linear kinematics lens, as the paddle hits the ping pong ball, we are able to study the motion of the ball in velocity and acceleration with respect to time. Using the equations, velocity is equal to the change in position divided by the change in time, and acceleration vector is equal to the change in velocity over the change in time. The tracker software is able to use these displacement data, change in time, and these equations to find the velocity and acceleration of the system. Two graphs we're able to see here are the displacement in the x and y direction with respect to time, x being the top and the y being the bottom graph. Here you can see the data points for time, displacement in the x direction, displacement in the y direction, and using the equation stated before, the tracker software was able to find the velocity and acceleration of each coordinate point. We're able to see the vector sum of the acceleration over time as the ball moves along the path.
I'm going to be talking about the energy of the ball throughout its travel. And to do this, I drew an x versus y graph because since the ball is hit at an angle, it has a vertical component to it and a horizontal component to it. So as the ball is hit, there's work being done onto the ball, which is shown in the form of kinetic energy. As the ball rises, the vertical component of the kinetic energy, the vertical velocity, will diminish because of the force of gravity acting on it. But there is no force acting on the horizontal component to it, so the horizontal velocity and therefore the horizontal kinetic energy will remain the same throughout this entire equation. But as the ball reaches its peak, because there's force of gravity pulling down on it, all of that vertical kinetic energy will be transformed into gravitational potential energy. And then after its peak, it will fall back down, being converted back into kinetic measurements and conversion factors. We found all of the data and we plugged it into our drawing, and then now we can start actually doing calculations. And so first we have to find the velocity to find the kinetic energy with it. And you can find the velocity is equal to change in x over change in t, and we can find the vertical velocity, the horizontal velocity, and the total velocity. The total velocity you find by using Pythagorean theorem and plugging in 0.28 meters and 0.33 meters into the equation to get a final value of 0.433 meters. And then you find that the vertical velocity is 1.26 meters per second, the horizontal velocity is 1.5 meters per second, and the total velocity is equal to 1.96 meters per second. So from here we can calculate the total kinetic energy. Kinetic energy total is equal to 1/2 mv total squared. Is equal to 1/2, and we know the mass of the ping pong ball is 0.0027 kilograms times 1.96 meters per second. Find that value to be 0.0052 joules. And then we can find the kinetic energy of the horizontal component and the vertical component by just plugging in the values to the formulas. And you find that the horizontal kinetic energy is 0.003 joules. And this stays relatively the same throughout the entire motion of this ping pong ball because there is very little change in velocity because there is no extra forces changing it. And then we find the kinetic energy of the vertical component to be 0.0021. And we know that all of this kinetic energy, the vertical kinetic energy, turns into gravitational potential energy. So kinetic energy is equal to gravitational potential energy. And gravitational potential energy is equal to mgh. And we know the mass of the ping pong ball is 0.0027 kilograms times 9.8 meters per second squared, which is the acceleration of gravity. And height is 0.28 meters, and this value turns out to be 0.007 joules. But why does this value not equal the previously stated kinetic energy of the vertical component, which we just said it has to equal? It does not equal that because there is loss of energy due to air friction that is causing a thermal energy component that we cannot yet solve. So that is why the numbers do not add up. We will analyze the energy after the ball has hit its peak, and to do that we need to use the Pythagorean theorem, and we find that the distance it traveled is 0.691 meters, and we can use our velocity formula, 0.691 meters over 0.34 seconds, because that's the time from when it hit its peak to when it hit the ground, and we find 2.03 meters per second. We use our kinetic energy formula, and we find that the final kinetic energy is equal to 0.0056 joules. But this is greater than the initial kinetic energy, but energy cannot be created or destroyed. But we find this extra energy because it dropped from a greater height. After the ball was hit in the air, it reached its peak, and then it fell all the way back down to the ground, therefore having greater gravitational potential energy, and that's where we find that extra energy from.